PCB Production Technology. The PCB Production Technology film is created at Resonit Tech Park for electronic design engineers. The production process shown in this film consists of 17 common steps. Multi-layer PCB manufacturing starts with the imaging of inner layer panels. The inner layer imaging process of a multi-layer PCB consists of the following stages. At the first stage, the inner layers pass through the chemical preparation line. A roughness develops on the surface of the copper, which is necessary for the best adhesion of the photoresist. At the next stage, the panels pass through the automatic lamination line. The dry photoresist film is applied on the panels using hot rollers. After cooling, the panels are transferred to imaging. That is, selective photoresist exposure, which takes place on direct laser imaging systems without the use of films. The exposed panels are stored for 15 minutes and then transferred to the development area. Unexposed sections of the photoresist are dissolved in the developing solution, exposing the copper that must be removed. The final stage of the development process is quality inspection, after which the panels are transferred to the etching of the inner layers. Etching is carried out in a horizontal conveyor machine. The copper unprotected by the photoresist is etched away, thus defining the pattern of the multi-layer PCB inner layer. Following the etching, the photoresist is completely removed in a special line for its removal. All of the inner layers of the multi-layer printed circuit boards pass through the automatic optical inspection machine. It allows for avoiding problems with the inner layer pattern, since after bonding, it won't be possible to make any corrections. The machine scans the panel, receiving a digital image of the etched pattern, and compares it with the reference pattern formed during the PCB's preparation for production. Any discrepancies found are presented to the operator for making a decision. Before bonding, an organic complex is deposited on the cleaned copper surface to develop the surface and improve adhesion. For positioning the inner layers between each other, the bonding machine is used. After assembly, the stack of inner layers is bonded together by a prepreg using induction heating. A panel placed between two separating plates makes a stack, which consists of the foil of the first outer layer, the prepreg, which creates a dielectric bonding layer, the stack of inner layers assembled on the bonding machine, the prepreg, and the foil of the second outer layer. The press forms are gathered together and loaded into a hot vacuum lamination press. During lamination, the panels are bonded into a single structure. After hot bonding, the panels are moved to a cold press for controlled cooling. Then, the press forms are taken apart and the laminated panels are transferred onto the registration holes drilling stage. This operation is used for the positioning of the hole drilling program, quality control of the bonding, and to align the inner layers. It is performed on a drill press equipped with an X-ray source and a camera. The system detects the registration marks on the inner layers, which are located on the four corners of each panel. The machine also checks for deformations of the panels after the bonding process, as well as the quality of the inner layers' alignment. For drilling the holes, the PCB panel is assembled into a stack. It consists of a lining material to eliminate burrs on the reverse side of the fiberglass, and the cover plates are made of aluminum to minimize the drift of the tool during the drilling process. The machine recognizes registration holes using optical cameras for precise alignment of the drilling program with the centers of the contact pads on the inner layers. The drilling process is controlled by a computer program containing coordinates and hole diameters. The machine selects a tool from a storage magazine, checks the length, diameter, and beat with the help of a laser measurement station. The contact drilling system ensures drilling with depth control, which is necessary for making blind holes in HDI multi-layer PCBs. The panels are transferred to the next operation, the choice of which is made according to the flowchart of the particular PCB type. To produce the initial conductive layer on the walls of the holes, a combination of three processes is used. The first step is the permanganate de-smear process of the holes. During the treatment process, a thin layer of epoxy resin is etched away from the edge of the inner layer and the walls of the holes. Then, to ensure adhesion of the coating to the fiberglass, a very thin conductive layer is created during direct plating. On top of the layer of palladium, a 5-micron layer of galvanic copper is deposited. The copper plating quality of each panel is controlled by the operator. Then they are transferred to the outer layer imaging area. In the first stage, the surface preparation equipment is used. A mechanical surface preparation using abrasive brushes for panels thicker than 0.5 millimeter is employed, while thinner panels pass through a chemical preparation line. The panels are cleaned of contaminants, and the copper surface becomes rough, which is necessary for the best adhesion of the photoresist. The photoresist is applied on the automated lamination line. The panels are gathered into a cassette and transferred to the imaging area. The direct laser imaging machine identifies the registration holes using optical cameras and verifies their location and diameter. If the panel complies with the quality criteria, the photoresist is selectively exposed with a UV laser. The combination of automatic print alignment and high-resolution printing provides for the imaging of PCBs up to 3 mil line space. Portions of the unexposed photoresist are dissolved in the developing solution, opening the holes and the pattern to deposit the galvanic copper. After a quality control inspection, the panels are transferred to the pattern plating area. The pattern plating produces a metal layer of the required thickness in the PCB's holes. The auto operator takes a jig with the panels and moves it sequentially through all the necessary preparatory steps, including surface cleaning, micro-etching, and pickling. Further, the fly bars with the panels are plunged into the copper plating bath for 60 minutes. To ensure good conductivity, about 25 microns of copper are deposited onto the walls of the holes as well as on the surface of the conductors and contact pads. As a result, with an initial thickness of 18 microns, the total thickness of the base and electro-deposited copper will be 35 to 40 microns. In subsequent operations, 5 microns of electroplating tin is deposited over the electro-deposited copper in order to protect the pattern during the etching. The coating process is controlled by a computer to provide the required parameters of the plating. After coating, the thickness of the deposited copper is tested by a non-destructive method. Before etching, the photoresist layer is removed from the panels, exposing the underlying copper layer that must be removed. The pattern of the PCB and the plated holes remain protected by an electronically deposited tin layer. The copper unprotected by the tin is etched away to define the pattern of outer layers. After etching, the layer of tin is removed. The panels are then transferred to the automatic optical inspection area for a quality control inspection of the etching. The outer layer's automatic optical inspection system scans the panel, receiving a digital image of the etched pattern, and compares it with the reference pattern formed during the PCB's preparation for production. In this case, not only is the quality of the etching controlled, but also the diameters and the hole positioning tolerances. The tested panels are transferred to the solder mask application area. In this stage, the solder mask is applied, the mask openings on soldering points are formed, and the final curing of the mask layers occurs. Before applying the mask, the copper surface is cleaned, then the necessary roughness is developed for the good adhesion of the solder mask. Liquid solder mask is pressed with a squeegee through a screen over the entire surface of the panel on the screen printer. For double-sided PCBs, the process is repeated. The applied layer is dried in the oven until a dry surface is formed. In the direct imaging machine, the solder mask is selectively exposed by UV light. Non-exposed areas of the solder mask are washed away on the processing line. The controller verifies the quality of the mask layers obtained. After inspection, the panels are placed in an oven for the final curing. To identify the components for assembling PCBs produced, there is legend printing. The image is formed by ink droplets hardened by UV light. After the quality control inspection, the panels are transferred to the surface finish application area. For coating the pads with tin lead solder, a hot air solder leveling method is applied. The panels pass through the preparation line where they are cleaned, and then the flux is applied. The prepared panel is plunged into a bath of molten solder for a few seconds. The solder covers all the open copper sections of the panel. During extraction, the excess solder is then blown off with hot air, and a thin, even coating remains on the pads. After cooling, the flux residue is washed away on the cleaning line. The panels coated with solder pass through midpoint quality control. Covering the pads with immersion gold is performed on a line equipped with an auto operator. The automated line allows for precisely maintaining the processing time to achieve a consistently high-quality coating. The panels are collected in the cassette and pass the stages of preparation, cleaning, micro-etching, and activation. Next, the cassette is plunged into a nickel electroplating bath for 22 minutes. About 0.06 of a micron of gold is deposited on the surface of the 5-micron layer of nickel. In the coating process, the parameters of the solution are monitored and adjusted automatically with the help of dispensers. After the final rinsing and drying, the panels pass through quality control. The multi-layer printed circuit boards coated with a finishing coat are transferred to the electrical testing area. Using the program put together at the PCB's preparation stage, the machine verifies all nets for integrity, continuously touching the contact pads. At the second stage, the adjacent nets are checked for reciprocal contact. This test ensures that during the production process, all nets were replicated correctly. Depending on the type and complexity of the contour of the printed circuit board, the optimal method of mechanical processing is selected. For straight line contour of multiplied PCBs, the V-scoring, or simultaneous cutting of multiple panels on both sides with disc milling cutters, is used. For complex contour, milling is used. The machine is equipped with an optical camera for the accurate alignment of the milling program with the PCB pattern, which is especially important for the manufacturing of HDI printed circuit boards. The additional measuring system makes possible milling with depth control and holes countersinking. The presence of a tool cooling system for the V-scoring and milling machines allows for processing the PCBs on a metal base. The PCBs are washed in deionized water using ultrasound to remove dust and contaminants from mechanical processing. After that, inspectors carefully examine every PCB to eliminate the possibility of any technological or cosmetic defects. In order to avoid moisture for ensuring a longer-lasting solderability, the PCBs are wrapped in vacuum packaging with moisture-absorbing materials. Next, the PCBs are transferred to the finished goods warehouse for customer delivery.